for understanding demand theory and consumer behavior, there are various approaches. But the first approach that we will be taking up over here is the cardinal utility approach. After understanding this module, after studying this module, you will be able to know the assumptions of the cardinal utility analysis. You would know the concept of total utility and marginal utility. You would understand the law of diminishing marginal utility and the law of equimarginal utility. You would be able to describe the relationship between total and marginal utility, derive the consumer equilibrium through cardinal utility analysis, derive a linear demand curve and derive a nonlinear demand curve. Now, as for the basics of the cardinal utility approach, let us first try to look at some of the background theory. From time to time, various theorists have attempted to explain consumer behavior and demand. The demand for a product, and they have seen various aspects of demand in terms of utility, price, quantity demanded and so on. And all of this has been put together to develop a valid demand theory. Cardinal utility theory has been explained in this module, in which is the oldest kind of approach for understanding demand. In cardinal utility, the attempt is to explain the consumer demand for both products as well as services in terms of law of demand states that there exists an inverse relationship between the price of a product X and the quantity demanded of the product X. This is a general way of defining it, although as we go along we will see that there are certain other aspects to the law of demand which have to be kept in mind. So, in this module we shall be dwelling upon cardinal utility analysis, on the basis of which we will be studying demand theory, law of demand, and deriving a linear demand curve and a non-linear demand curve. First of all, let us look at the cardinal utility analysis in its basics. What do we mean by the term utility? And then let us see what cardinal utility analysis in particular tells us about utility analysis and so on. Utility analysis is the core concept in the theory of consumer behavior. Even the subsequent theories which we will be examining cannot do without a notion of utility. There may be different notions which are attributed. Some of them look at utility in absolute terms as cardinal utility approach looks at it. Some of them look at it in relative terms and so on. But on the whole, utility is the basis of consumer behavior. We all know that there are unlimited human needs and wants, and there are all kinds of economic activities through which the aim is to fulfill these unlimited wants. Utility can be defined as the characteristic of a product or service to satisfy the property that a product or service has to satisfy these human wants. So basically utility is something which is a measure of satisfaction. In other words, the amount of satisfaction that a consumer derives from the consumption of a product or service is known as utility. At this stage, it is important to clarify that utility is not the same thing as satisfaction. Satisfaction is something which may or may not be measurable, but in the cardinal utility approach, we assume that utility is measurable. Utility refers to the expected satisfaction, and the satisfaction stands for the actual satisfaction that has realized. That is, utility emerges whenever a consumer thinks of buying a commodity. On the other hand, satisfaction emerges only after the consumer has actually consumed the product or availed of the service. Thus, it can be said that a consumer can derive utility from a commodity in an imaginary sense even without purchasing it, because utility indicates the expected satisfaction. However, satisfaction can be derived only after consumption of the good or service. The cardinal utility approach is also known as the classical approach, classical method of understanding demand analysis, demand theory, because it was presented by the classical economists such as Alfred Marshall. According to this approach, it is possible to measure utility and express utility in quantitative terms. This is the core of the cardinal utility approach. Since utility can be measured and quantified, it is also possible to compare the utilities of two commodities or compare the utility from two units of consumption of the same commodity. It is also possible to measure the total utility that is obtainable from the consumption of a large number of units of the same commodity. But there are certain conditions which have to be observed. Now, these conditions can be and are incorporated into the basic assumptions of the cardinal utility analysis. So, now let us look at the assumptions of cardinal utility analysis. The assumptions are based on the certain psychological and behavioral aspects of the consumer. Now, before explaining cardinal utility and the consumer's behavior and equilibrium and the demand for a commodity, let us first now take up these assumptions. The most fundamental assumption is the theory in the theory of cardinal utility is rationality. Rationality, in the case of rationality, the theory assumes that the consumer is rational, which implies that given a choice, the consumer would always choose more rather than less. The objective, therefore, of a consumer is to maximize utility. Hence, maximization of utility is a sign of rationality. Never would the consumer choose less than something which is being offered if there is a choice and if the consumer can get more utility out of this situation, out of a decision to consume. The cardinal utility analysis is also based on the second assumption that utility is measurable. Consumers can measure not only the in value terms, in absolute terms, the utility obtained from the consumption of each unit of a commodity, but they can also measure the change in utility between two units of consumption of the same commodity. Now, this change in the total utility which is occurring due to one additional unit of consumption is known as marginal utility. That is, the extra utility derived from the consumption of each additional unit of consumption is known as marginal utility. In other words, marginal utility is the change in the total utility resulting from one unit of additional consumption of a commodity or a service, but please remember that marginal utility has to be measured only at a given point of time. We will discuss more about this as we go along, but it is pertinent to remember that utility has to be measured at a point of time. The process of consumption and the process of obtaining utility out of it and the implications for marginal utility crucially depend upon this assumption of having consumed at a point of time. Now, we have another very important assumption. This assumption is very often ignored, the constant marginal utility of money. In cardinal utility analysis, it is assumed not only that utility can be measured, but that the marginal utilities decrease or diminish with an extra unit of consumption, and this is known as the law of diminishing marginal utility. However, when the marginal utility of money remains constant throughout, this is an assumption that the marginal utility of money remains constant when the individual is spending more or less money on certain goods and services, or when the price of those goods and services are increasing or decreasing. Then when we are measuring utility in monetary terms, it is necessary, at least for the time being, to assume that there is constant marginal utility of money. That means marginal utility can be measured in absolute terms, but for expressing it we need some kind of medium. If that medium is money, then to begin with at least we are assuming that the marginal utility of money itself is constant. We need to have, when we are measuring something, then it is necessary to have a fixed standard of measurement, and that is why we assume that the marginal utility of, first of all, we are measuring that utility can be measured in money terms. Secondly, we are assuming that the marginal utility of money is constant irrespective of whatever changes are taking place in terms of price and other variables. Then we have the assumption of diminishing marginal utility. In the cardinal utility approach, this is the all-important assumption. As consumption of a commodity increases, the utility obtained from every successive unit of consumption decreases. A further assumption is that all the units are consumed at a given point of time. That is, there is no time gap between the consumption of successive units. Otherwise, the utility may in fact not decline. So now you realize what is the importance of the assumption of consuming at a point of time. So earlier when we defined the law of demand as a inverse relationship between price and quantity demanded, at that point we did not consider and make it clear that a fundamental assumption is that demand is the law of demand holds good at a point of time. We will be looking at more of this as we go along. Now about total utility, we said that the consumer is rational. When a consumer is rational, then it means that the consumer always would like to have more rather than less. So a rational consumer's objective is to maximize the total utility. Now total utility depends upon the consumption of a basket of goods. You are very much aware that an individual consumer or a household would be consuming various commodities and services. For example, the basics are food, clothing, shelter, etc. So therefore, if we talk about demand analysis, if we talk about demand theory, if we talk about consumer behavior, then it is obvious that a rational consumer would like to maximize the total utility, and the total utility is obtained from the consumption of different units and quantities of each good or service. So this is the fifth assumption. There are 5 basic assumptions for cardinal utility analysis. Now let us look at consumer equilibrium in cardinal utility analysis. Let us first consider the total utility function, that is, U is a function of x1, x2, x3 and so on up to xn. U stands for the utility, which is on the left hand side. You would notice that this is total utility, and on the right hand side we have a small f. Now this f stands for the functional relationship. That means utility is a function of consuming various goods and services ranging from x1, x2, x3 up to xn. So xn are different commodities. At this stage we don't have to distinguish between commodities in the sense of being goods or services, right? So therefore, now the consumer plans to buy all commodities from 1 to n. Suppose the commodity number 1 is x1, then the expenditure on 1 is ex1. So therefore, the total expenditure would be ex1 plus ex2 plus ex3 up to exn. The summation of the total expenditure would be equal to the total income of the consumer. Now, given the prices of each commodity, the question arises as to how the consumer will decide how much of the quantity of each commodity should be. That is, how much should he consume and purchase of commodity x1, and the answer to that would depend upon how much utility the consumer gets from the consumption of x1. Okay. So the utility of x1 is a function of the consumption of x1. Now let us discuss that. As discussed in assumption number 1 and 2, the utility is measured in money terms, and a rational consumer would like to maximize the utility. Okay. So, a rational consumer attempts to consume different commodities. For the time being, we are considering one commodity X1, and in the process the consumer is measuring the utility in money terms. Also, as consumption increases, we know according to assumption 4 that as consumption increases, the total utility increases, but the marginal utility declines. This is according to the law of diminishing marginal utility, which is assumption number 4. Now, we rewrite the equation number 1. Okay. The utility of x1 minus the function of the quantity of x1 is equal to 0, and this becomes equation number 2. And in terms of the marginal principle, the total benefit is denoted as ux, that is measured in monetary terms, while the cost or the expenditure is ex, and that is the price multiplied by the quantity of commodity 1. Now, for maximizing the utility obtained from commodity x1 ux1, equation 2 has to be differentiated with respect to quantity. That is, when quantity is increasing, we differentiate the utility function and equate it to 0. This is the common process of maximization. So, we rewrite equation number 2 as follows, that is, utility of x1 minus price of x1 multiplied by the quantity of x1 is equal to 0. Now, this will be numbered as equation number 3. Now, maximizing equation 3, we get the following: differentiation of ux1 with respect to qx1 minus the differentiation of px1 multiplied by qx1 with respect to qx1. Thus, by solving this, we get the next equation, equation number 4, which is that marginal utility of x is equal to price of x. And this is what we call the equilibrium condition, because the equilibrium condition is leading to the maximization of utility with a constraint of the given price of the commodity x1. In general, equation 4 can be now generalized. So far we were talking about only one commodity, but please remember that when we talk about a consumer, when we talk about maximization of the objective of the consumer, then a consumer is getting utility from a range of commodities. Therefore, to generalize equation 2, it is necessary to apply this equilibrium condition to more commodities. Similarly, therefore, mu of y is equal to p of y, and just as we have mu of x is equal to p of x, we have mu of y is equal to p of y, and this we can call it equation number 4a. Now, for maximizing the consumer satisfaction, we divide equation 4 by equation 4a. Therefore, mu x divided by mu y is equal to px divided by py. And similarly, what we can do is to extend this to a number of other commodities as well. As such, this could be designated as equation number 5. For a multi-product consumption utility analysis, equation number 5 can be further elaborated. So, what we can say is, in general, mu x by px is equal to mu y by py is equal to MUK by PK and so on up to MUN by PN. This is equation number 6, and now you can clearly see that equation number 6 is actually telling us what is known as the law of equi-marginal utility. Now we shall reconsider equation number 4. In equation number 4, we know that marginal utility of x is equal to price of x. Here, however, we have ignored the fact that marginal utility is being measured in terms of money. Therefore, there is an assumption that marginal utility of money MUM is constant, and hence we have to introduce marginal utility of money into this equilibrium condition. Hence we can say P of x is equal to marginal utility of money multiplied by marginal utility derived from the consumption of 1 unit of x. Okay? So that is MUX. Therefore, now let us look at this condition and try to derive a linear demand function. If we are measuring marginal utility, and let us consider marginal utility to be a step function, that means for each unit of consumption, the marginal utility derived from that unit is discrete. Therefore, if you look at the diagram, you would see that it is in the nature of a step function. When the consumer consumes one more unit of commodity X, then what happens is that the marginal utility falls by an amount of delta MUX, that is the fall in the marginal utility. Parallelly, if you look at the second part of the diagram, then you would see that we have price on the y-axis and we have quantity demanded on the x-axis. In the case of the utility function, it is consumption. In the case of the demand function, it is actually quantity demanded. But these two are identical, because when we measure marginal utility in money terms, and secondly, when we give up the assumption of discrete marginal utility and convert it into a continuous function, then the marginal utility is falling continuously for each fractional unit of consumption. That is how we get a linear downward sloping demand curve, which is nothing but the exposition of the law of demand as we understand it. Continuously, as price of a commodity falls, the quantity demanded increases. This is how we can say that a demand curve is nothing but a marginal utility function measured in terms of money. However, please remember, given the assumption that marginal utility of money is constant. Okay. So now let us give up this assumption of marginal utility of money being constant, and then we can understand how we can derive a convex demand curve. Okay. Now, when price goes down, then what happens? The real income increases. When real income increases, assumption number 3 tells us that according to assumption number 3, marginal utility of money is constant. But now this will not hold good. Can you imagine that a rich person will not have the same value for each rupee that he or she is spending? As they have more and more of riches, they have more and more of income, they would value every additional rupee less and less. So therefore, if we relax the assumption of marginal utility of money being constant, then we have to re-examine what is happening to the relationship between marginal utility of commodity X and its price. Now suppose we consider the price to fall in a constant manner, that is delta Px is equal. Okay, let us say the price falls by 5 rupees for commodity X every time. Okay, but then on the left hand side of the equilibrium condition, you have delta Px. This delta Px has to be equal to the delta of the marginal utility on the right hand side, delta Mux. But delta Mux is also multiplied by a declining marginal utility of money. So if marginal utility of money is declining, and if this equation has to be in equilibrium, then it stands to reason that marginal utility of commodity X has to decline slower. Therefore, what happens is that with declining marginal utility of money, for equal measures of the fall in the price, the demand function will begin to fall slower and slower. Now this is very similar to what we will be seeing in the next module in terms of indifference curves. But for the time being, it would be apparent, if you look at the diagram, what we will see is that as price falls, the step function which is representing marginal utility has got larger and larger bars, but it is spaced out at a further length. Therefore, this means that utility is falling slower and slower. If we join all the vertices of these bars of the marginal utility function, then you will face a continuous downward sloping function which is the demand curve, but you would notice that the demand curve so derived is convex to the origin. This is how we arrive at a demand curve which is convex to the origin. Now let us summarize what we have studied. In this module, we have studied the concept of utility. We have studied the assumptions of utility analysis, that is cardinal utility analysis. We have, through cardinal utility analysis, we have explained consumer behavior, consumer demand. We have understood the law of diminishing marginal utility, the law of equimarginal utility, and how a consumer maximizes the utility through the law of equimarginal utility. We have derived the consumer equilibrium condition in the cardinal utility approach. Then through this condition we have derived a linear demand curve, and then after relaxing one crucial assumption that marginal utility of money is constant, we are able to derive a non-linear demand curve which is convex to the origin.